So I started looking at it, and lo and behold, there's lots of times where this could happen. Okay, it doesn't look like a lot, but if you want to cook on your oven, and this is that time, it's important time, right? So you have to keep in mind this battery capacity. Okay. Same thing for generators. Even if you're combining a generator and a battery, okay? When you're talking microgrids, you're talking a smaller genset that doesn't have a lot of rotational inertia to it. Okay? One of the reasons that the grid is so good at surviving transient events, and when I say transient, I mean like 2 to 3 cycles of the electric waveform, right? So there's this AC waveform. When you go to turn on a motor, if that's a big motor, that motor looks like a short circuit. It looks like you've just taken the 2 wires out of the wall and hooked them together, okay? The grid can handle this because behind it, it has these massive turbines that have inertia, okay? They don't slow down. If the power cuts out, it's because there's been a protection device, like a circuit breaker or something like that. When you're talking little generators, they actually have electronics to turn the output of that generator into something that is going to power your devices. So do the battery inverters here. They have to be protected so much faster than the grid with its inertia, that what would happen is if I tried to run in this range, the inverter would just cut itself off. Now luckily the system had the protections. It would go to that mode 5, that bypass, and the worst case thing that the homeowner would see would be the lights would flicker, okay, because I went back onto the grid. But if you're talking about something that is someplace where there is no grid to go back to, you have to keep that in mind, okay? The system will shut itself down and somebody has to go reset it. Now I had software to reset it, but you don't want to be trying to turn on a microwave or something like that, or anything relatively large, and have the system blinking out on you, okay? We actually had this problem when we first fielded the units, because I went and looked, and I'll admit I did a bad job at this. I went and looked at a couple of air conditioning units and solved something called lock rotor current. Okay, I knew what it was, I knew what I was looking for, but I didn't look at enough units. I went and only looked at a couple, and for 2.5 ton AC systems, I saw lock rotor currents that were between 35 and 40 amps. Okay? Well, the batteries could handle that, the inverters could handle that, I was fine. The very first house that we installed in had a slightly larger AC system that didn't do nearly as good of a job at those at limiting that lock rotor current. It drew 120 amps. There's a factor of 5 to 1 across some of these devices. Okay, so now we go to turn this system on, and it's working great. The guy's AC unit comes on, it stops. We had to retrofit his equipment with something called the soft start circuit. Okay, so there's all these things that you have to think about. Yeah, let's skip that. All right, so I'm going to stop there. Now that I see some scared looks of, oh God, what did we get ourselves into? I'm going to stop there and ask for questions. Okay, and I see what time it is. I can go past a little bit past 7. It's 6:40, so I can go a little bit past 7. So, what questions do you have?
Could you go back to the slide with the load distribution, so where you...
The colorful one at the beginning?
Yes.
That one?
Yes.
Okay.
So when the AC suddenly comes on, it's obviously a big addition to the grid. Does that lead to sudden strains to the grid? And
Absolutely.
And then another question I have is, I've heard that when that happens, the grid actually ends up losing money because you pay the same rate, but the utilities have to pay peak energy prices because
That's correct.
of that.
That's correct.
So could you explain a little bit about
Sure.
those?
So there's 2 things here. There's what happens economically, right? And I know just enough economic policy and Public Utility Commission policy to be dangerous. I know enough that when I go to these places, I can really annoy them by telling them what they should do, right? And then there's the technical aspect of what happens. Okay? So let's start with the technical aspect of what happens. I'm going to back up and explain how electricity is generated, and then how you do that in a microgrid basis. Okay, what the difference is, and then that way I can kind of explain why this becomes an event. All right. So in a traditional utility, you have many generation sources. I don't remember how many gas-fired, coal-fired, nuke, wind, solar plants that ERCOT tracks, but it's thousands, okay? And they range in capacity. There's gigantic units that run something called baseload, which is when you add up all the houses and all the businesses, that load never goes below that. And they have very long-term contracts for those devices, because now you know you're going to need to provide energy. You know that you've got a place to put it. You know you have a buyer.